So let's start with the module 5, important concepts of business intelligence. So what are the main concepts of BI? What are the different types of analysis? What are the different types of systems? We will see in this module. So in this session, we will discuss about context analysis and trend analysis and understand the importance and different types of context analysis and trend analysis and what some use cases.
In our next module, we will discuss about important aspects of this intelligence. The important aspects of business intelligence are context analysis, business performance management, business process discovery, information system, information intelligence, and process mining. The methods to analyze the environment of any business is known as context analysis. So start the module. We will start with context analysis. Context analysis refers to a method of sociological analysis associated with which believes that given act, be it a glance at a person, a shift in posture, or a remark about the weather, has no intrinsic meaning. Such acts can only be understood when taken in relationship to one another. Context analysis is a method to analyze the environment in which business operates. Environmental scanning may focus on the macro environment of a business, but context analysis considers the entire environment of the business, its internal and external environment. This is an important aspect of business planning. One kind of context analysis called SWOT analysis allows the business to gain an insight into the strength, weakness, and opportunities and threats posed by the market within which they operate. The main goal of a context analysis, SWOT or otherwise, is to analyze the environment in order to develop a strategic plan of action for the business. Context analysis considers the entire environment of a business, internal and external environment. goal is to highlight the environment in order to develop a strategic action for the business. The first step of the method is to define a particular market. One wishes to analyze and focus all analysis techniques on what was defined. A subject, for example, can be a newly proposed product. Next, we'll discuss about trend analysis. Trend analysis is an analysis of factors in the external environment of a business, also called pest analysis. It consists of analyzing political, social, technological, and demographic trends. This can be done by first determining which factors on each level are relevant for the chosen subject and for each item and to specify its importance. This allows the business to identify those factors that influence them. They cannot control these factors, but they can try to cope with them by adapting themselves. The trends that are addressed in pest analysis are political, social, and technological. But for context analysis, demographic trends are also important. Demographic trends are those factors that have to do with the population, like average age, religion, education, etc. Demographic information is important. For example, in market research, the business wants to determine a particular market segment to target. Are described in environmental scanning pest analysis. And only covers part of the external environment. Aspect of the external environment the business should consider is competition. This is the step of the method called competitor analysis. next is competitor analysis. Competitor analysis is important for a business to know who its competition is, how they do their business, and how powerful they are, so that they can be on the defense and offense. In competitor analysis, a couple of techniques are used for such an analysis. Determination of competition levels, competitive focus, competitive forces, competitor behavior, and competitor strategy. The first is competition levels. Business compete on several levels, and it is important for them to analyze these levels so that they can understand the demand. Competition is identified on 4 levels: consumer needs, general competition, branding, product. Consumer needs is a level of competition that refers to the needs and desires of consumers. A business should ask, what are the desires of the consumers? General competition is a kind of consumer demand. For example, do consumers prefer shaving with electric razor or a razor blade? Brand refers to brand competition. Which brands are preferable to a consumer? Product refers to the type of demand. What types of products do consumers prefer? Then we have competitive forces. These are the forces that determine the level of competition within a particular market. There are 6 forces that have to be taken into consideration: power of competition, threat, new, and bargaining powers of the buyers and suppliers, threat of substitute products, and the importance of complementary products. behavior. Competitor behaviors are the defensive and offensive actions of the competition. A competitor strategy. These strategies refer to how an organization competes with other organizations. These are low price strategy and product differentiation strategy. Next is opportunities and threats. This is to determine threats and opportunities posed by the market. The trends analysis reveals a set of trends that influence the business in either a positive or a negative manner. These can be classified as either opportunities or threats. Similarly, the competitor analysis revealed positive and negative competition issues that can be classified as opportunities or threats. Then we have organization analysis. The last phase of the method is an analysis of the internal environment of the organization. Thus, the organization itself. The aim is to determine which skills, knowledge, and technological factors of the business process. This consists of conducting an internal analysis and competence analysis. Then we have internal analysis. Involves identifying the organization's strengths and weaknesses. Strength refers to the factors that can result in a market advantage, and weakness the factors that give a disadvantage because the business is unable to comply with the market needs. Then we have strategic plan. The ultimate goal of context analysis is to develop a strategic plan. The previous topics described all the steps that form the stepping stones to develop a strategic plan of action for the organization. The trend and competitive analysis gives insight to the opportunities and threats in the market, and the internal analysis gives insight to the competencies of the organization. So let's see what is the trend analysis. The environmental factors one should consider are as follows. Political trend. Environmental trend, economical trend. Social trend, technological trend. Political trend refers to intellectual property rights. Economical trend refers to economic growth. Social trend refers to reducing the operational costs, ease of conducting business administration. Technological trend refers to software suites and web application. Next is competitive analysis. So in this we have competition level, competitive forces, competitive and competitive strategy. competition level, we have consumer need, brand, and product. In competitive forces, we have the bargaining power, effect of new entries, power of competition. Then competitor behavior. The focus of the competition is to take over the position of the market leader. The competitor strategy. One intends to compete based on product differentiation.
Next, we'll understand about MapReduce. MapReduce is a computational component of the Hadoop framework for easily writing applications that process large amounts of data in parallel and stored on large clusters of cheap commodity machines in a reliable and fault-tolerant manner. MapReduce can perform distributed and parallel computations using large datasets across a large number of nodes. A MapReduce job usually splits the input datasets and then processes each of them independently by the map tasks in a completely parallel manner. The output is then sorted and input to reduce the tasks. Both job input and output are stored in file systems. Tasks are scheduled and monitored by the framework. So MapReduce can perform distributed and parallel computations using large datasets across a large number of nodes. A MapReduce job usually splits the input data sets and then processes each of them independently by the map tasks in a completely parallel manner. The output is then sorted and input to the reduce tasks. Both job input and output are stored in file systems. Tasks are scheduled and monitored by the framework. So how does MapReduce work? MapReduce Architecture contains two core components as daemon services responsible for running mapper and reducer tasks, monitoring and re-executing the tasks on failure. In Hadoop 2, Resource Manager and Node Manager are the daemon services. When the job client submits a MapReduce job, these daemons come into action. They are also responsible for parallel processing and fault tolerance features of MapReduce jobs. In Hadoop 2 onwards, resource management and job scheduling or monitoring functionalities are segregated by yet another resource negotiator as different daemon. Compared to Hadoop 1 with job tracker and task tracker, Hadoop 2 contains a global resource manager and application masters for each application. The job client submits the job to the resource manager. Yet another resource negotiator, resource manager's scheduler, is responsible for the coordination of resource allocation of the cluster among the running applications. Yarn node manager runs on each node and does the node level resource management, coordinating with the resource manager. It launches and monitors the compute containers on the machine, on the cluster. Application master helps the resources from resource manager and uses node manager to run and coordinate the MapReduce tasks. So this is the MapReduce architecture. The MapReduce job to the job client, and thereafter it coordinates with resource manager, and then it goes to the data node where it has application master and the container. So like this, the MapReduce coordinates the job between the resource manager and the app manager. So HDFS is usually used to share the job files between other entities. So what are the phases of the MapReduce model? MapReduce model has 3 major and 1 optional phase. So the first phase is mapper. It is the first phase of the MapReduce programming and contains the coding logic of the mapper function. The conditional logic is applied to the n number of data blocks spread across various data nodes. The mapper function accepts key value pairs as inputs as k, b, where the key represents the offset address of each record and the value represents the entire record content. The output of the mapper phase will also be in the key value format as k dash, v dash. Then shuffle and sort. The output of various mappers then goes into shuffle and sort phase. All the duplicate values are removed and different values are grouped together based on similar keys. The output of the shuffle and sort phase will be key value pairs again as key and array of values. Then reducer. The output of the shuffle and sort phase will be the input of the reducer phase. In this phase, reducer function's logic is executed and all the values are aggregated against their corresponding values. Reducer consolidates outputs of various mappers and computes the final job output. The final output is then written into a single file in an output directory of HDFS. Finally, the fourth phase is the combiner phase. This is an optional phase in the MapReduce model. The combiner phase is used to optimize the performance of the MapReduce jobs. In this phase, various outputs of the mappers are locally reduced at the node level. For example, if different mapper outputs coming from a single node contains duplicates, then they get combined, that is locally reduced as a single key value array output. This phase makes the shuffle and sort phase work quicker, thereby enabling additional performance in MapReduce jobs. So all these phases can be shown with the diagram as shown on the screen. So the block 1, block 2, block 3, and block 4 is a key value pair, which is output as key dash and B dash to the combined phase, which outputs the result as the key and array of values, and that becomes the input for the reducer phase, and then we get the output. So for example, the MapReduce logic to find the word count on an array of words can be done as follows. Let's see how it can be done. So first we will take fruit array equals apple, orange, apple, guava, grapes, orange, apple. The mapper phase tokenizes the input array of words into the n number of words to give the output as KB. For example, consider apple. Mapper output will be apple, 1, apple, 1, and apple, 1. Then the shuffle and sort accepts the mapper k, v and groups all values according to their keys as k, arrays of values. That is apple of 1, 1, 1. The reducer phase accepts shuffle and sort output and gives the aggregate of the values, that is apple, 3. So next is speculative execution of MapReduce work. The speed of MapReduce is dominated by the slowest task. So to up the speed, a new mapper will work on the same data set at the same time. Whichever completes the task first is considered as the final output, and the other one is killed. It is an optimization technique. So what are the benefits of MapReduce? So the first one is fault tolerance. Then we have resilience. Then it is quick. Then we have parallel processing. Availability. Scalability. And finally, cost effective. So during the middle of a MapReduce job, if a machine carrying a few data blocks fail, architecture handles the failure. It considers replicated copies of the blocks in alternate machines for further processing. Then resilience. Each node periodically updates its status to the master node. If a slave node does not send its notification, the master node reassigns the currently running task of that slave node to other available nodes in the cluster. So data processing is quick as MapReduce uses HDFS as the storage system. MapReduce takes minutes to process terabytes of unstructured, large volumes of data. MapReduce tasks process multiple chunks of the same datasets in parallel by dividing the tasks. This gives the advantage of task completion in less time. Multiple replicas of the same data are sent to numerous nodes in the network. Thus, in case of any failure, other copies are readily available for processing without any loss. Hadoop is highly scalable platform. Traditional RDBMS systems are not scalable according to the increase in data volume. MapReduce lets you run applications from a huge number of nodes using terabytes and petabytes of data. Then cost effective. Hadoop's scale out feature along with MapReduce programming lets you store and process data in a very effective and affordable manner. Then cost savings can be massive as figures of hundreds for terabytes of data. So modern data is moving more towards the unstructured type and huge. Conventional data processing option like RDBMS is even more difficult, time consuming and costly. But Hadoop's MapReduce programming is much effective, safer and quicker in processing large data sets of even terabytes or petabytes. Next, we will see types of data model. For the creation of any database, the data model is considered a logical structure for creating a database. The data model includes entities, attributes, constraints, relationships, etc. The data model is used to represent the data and how it is stored in the database, how data is accessible and updated in the database management system. There are 4 types of data models: hierarchical model, network model, entity relationship model, and relation model. These models have further categories which are used according to a different use case. So what are the different types of model? Let's discuss the first one, that is hierarchical model. So in this type of data model, the data is organized into a tree-like structure that has a single root, and the data is linked to the root. In this model, the main hierarchy begins from the root and it expands like a tree that has child nodes and further expands in the same manner. In this model, the child node has one single parent node, but one parent node can have multiple child nodes. As the data is stored like a tree structure in this data model, when data is retrieved, the whole tree is traversed from the root node. The hierarchical data model contains a one-to-many relationship between various types of data. The data is stored in the form of a record and is connected through links. In this model, the child node has one single parent, but one parent can have multiple child nodes. As the data is stored like tree structure in this data model, when data is retrieved, the whole tree is traversed from the root node. The hierarchical data model contains a one-to-many relationship between various types of data. The data is stored in the form of a record and it's connected through links. For example, there is an organization that has a requirement to store the information of its employees. The table contains the following attributes: employee name, employee code, department name, and last name. The organization provides a computer for each employee. So there is a requirement for storing information on a computer, which is stored in a separate table. The computer table stores employee code, serial number, and type. According to the hierarchical data model, the employee table can be considered as a parent table, and a computer table can be considered as a child node. Then we have network model. The network model is a type of database model which is designed based on a flexible approach for representing objects, and the relationship exists among objects. The schema is a very important in the network data model, which can be represented in the form of a graph where a relationship is represented using edges, and the nodes are used to represent objects. The basic difference between the hierarchical model and network model is that data is represented in the form of hierarchy in a hierarchical data model, whereas in network model, the data is represented in the form of a graph. One of the advantage of a network model is that the basic connections are also represented in this data model. There are different types of relationship can exist in this data model, like one-to-one, many-to-many, etc. The data access becomes simple to compare to other data model, like the hierarchical model. The parent node and child node are always connected, as there is always a relationship among parent-child node. And the data is not dependent on the other node. One of the key drawbacks of this model is that this system is not adaptive towards changes. It means when there is a requirement of some modification of system. It requires to change the whole system, which takes a lot of effort. And to maintain data is difficult to part in this model, as every record is connected via some pointers, which makes it difficult to maintain and make the system complex. So the basic difference between the hierarchical model and network model is that data is represented in the form of hierarchy in a hierarchical data model, whereas in the network model, the data is represented in the form of a graph. One of the advantages of a network model is that the basic connections are also represented in this data model. So there are different types of relationship in this data model, like one-to-one, many-to-many, etc. The data access becomes simple to compare to other data models like hierarchical model. The parent node and child node are always connected, as there is always a relationship between the parent and child node. Data is not dependent on the other node. One of the key drawbacks of this model is that this system is not adaptive towards changes. It means when there is a requirement of some modification of system, it requires to change the whole system, which takes a lot of effort. And to maintain data is difficult to part in this model, as every record is connected via some pointers, which makes it difficult to maintain and make the system complex. Next is ER model. The ER model is used to describe the database structure using the entity relationship diagram. The ER model is just like the blueprint of a database, which is used to implement the database. In the entity set, the relationship exists, which can be shown using the ER diagram. The entity set consists of a similar type of entities that consist of attributes. The components of the ER model are relationship set and entity set and attributes. The entity is the component of data, which is represented as a rectangle in the ER diagram. For example, there are two entities, college and student, and there exists one-to-many relationship, as there can be more than one student who goes to the college. So next we have relation model. So in this data model, the data tables are used to collect a group of elements into the relations. The relationships and data are represented using interrelated tables. And in the table, there are multiple rows and multiple columns in which column represents the attribute of the entity, and the rows are used to represent records. In this data model, there exists different primary key, which is used to distinguish each record in the table. And for retrieving the record and for retrieving the data elements, the SQL is used. For using the relational data model, the primary key issued as the fundamental tool. And for each entry in the data set, it needs to be unique. The data table should not contain any type of inconsistency, as it can create a problem at the time of data retrieval. The other problem with the relational data model is data duplicacy, incomplete data, and inappropriate links used to connect data. So for representing the database, there is a different type of data models which are used for representing the database structure. Each data model has its advantages and disadvantages, and the use of a data model is dependent on the use cases. Next, we will see introduction to test data generation. Test data is any input given to a machine learning model to test its performance and reliability. In order to obtain the machine learning models with excellent performance, it is important for the data scientist to train it with all possible variations of data and then to test the same model even more varied and complicated, yet with all-inclusive data. Often it becomes difficult to include all the scenarios and variations in the test data that is obtained after the train-test split. Hence, it becomes important to create a data set with all the use cases covered that can best measure the model performance. The process of generating such a data set is known as test data generation. In order to obtain the machine learning models with excellent performance, it is important for the data scientist to train it with all possible variations of data and then to test the same model with even more complicated data. The process of generating such a data set is known as test data generation. Rules of test data generation in machine learning. In today's world, with complexity increasing day by day and delivery time spans reducing, data scientists need to prepare the best performing models as soon as possible. However, models being created only becomes the best performing models once it has been tested on all kinds of scenarios possible. All these scenarios may not be possible for the data scientist to have with him, and hence he may need to create some synthetic data to test the models. Hence, to create these synthetic data sets, there are certain kinds of rules or guidelines you must keep in mind. You must observe the statistical distribution of each feature in the original of the real data set. Then accordingly, we need to create the test data with the same static distributions. We need to understand the effects of the interaction that the features have over each other or on the dependent variable. By this, we mean to say that we need to preserve the relations among the variables. Have a look at the univariate, bivariate relationships and try to have the same relationships when creating the test data. The data generated should preferably be random and normally distributed. In the case of classification algorithms, we need to control the number of observations in each class. We can either have the observations equally distributed to make the testing easy, or have more observations in one of the classes. Random noise can be injected into the data to test the machine learning model on anomalies. We also need to preserve the scale of values and variations in the features of the test data. That is, the values of the feature should be depicted correctly. Values of age should be around 0 to 100 and not some number in thousands, for example. We will need an extremely rich and sufficiently large dataset, which can cover all the test case scenarios and all the testing scenarios. Poorly designed test data may not test all possible test or real scenarios, which will hamper the performance of the model. We need to generate the dataset large enough so that not only the performance, but also the stress testing is done of the model and software platform. So these are the rules of test data generation in machine learning.